Hello. One of the most enjoyable things about studying architecture and indeed practicing it is that you're constantly surprised and encouraged by all the new projects which are constantly being published. And we all at some point decide which magazines we particularly enjoy reading and which ones we look forward to plopping through our letterbox onto the mat and ripping open the cover and reading about all the latest designs that are being produced all over the world. And when we open those magazines, we're often confronted with a combination of drawings, photographs, particularly photographs, images, sometimes the artist's sketches, and we learn about how the project came about and what the intention was of the architect and the client and the various consultants. So a typical page in a magazine, and one of my favourites, I've mentioned it to you, I know, in the lectures previously, is a German magazine. It's published with an English translation called Detail magazine. And you can see that the format is a little dry. The photographs tend to be black and white. The key plan and section, which is at the top of the left-hand page above the photograph, are very small. They're just the key bits, and the focus of the magazine is in really explaining how the architect has designed the building that you see portrayed in the photographs. And that's done in a detailed section, which is shown on the right-hand side of this section, right-hand side of the slide. And what I particularly encourage you all to do during this exercise, there are a series of about 15 examples coming up, is to be able to look at the photograph and then look at the plan and look at the section and work out where the photograph has been taken from, where the photographer had set up his camera in order to take that view. And by doing this, by sort of practicing putting yourself in the plan, putting yourself in the section, looking, in this case, slightly upwards, up the staircase, you will become familiar with understanding what the spatial arrangements are in plans and in sections as you see them printed in front of you. And so you can see the photograph is taken in the staircase. You can see from the plan less clearly, I think, than in the section, that this is a project which is about an old building with a big timber roof, with thick stone walls, with a new building, a new very subtle construction built inside. So it's a sort of box or a series of boxes within the shell of the old building. And that's reinforced by the section on the right. You can see the thickness of the old walls, the massive stone thicknesses, the timber windows that are right on the very face of those stone walls on the outside, the big timber truss at the top, and you can contrast that to the delicacy of the steel frame. It is a steel frame. You can see the I-beams in the detail section there, which support the structure of the inner box. And there's this gap, the gap between the inner box and the inside face of the external stone walls. And that's the zone that's occupied by this staircase. You can see the thick stone walls on the right of the photograph and the slickness of the flush glazing and plasterwork probably of the inner box. And you can see in the section above the photograph the fact that the photograph is taken looking up the staircase, and the section is cut at a point halfway up the staircase, but looking down the staircase. So you have to reverse in your mind's eye that section in order to get that view. What we're going to be asking you to do in the workshop following this talk is an analysis of the three fundamental elements that constitute a new design: the structure, the envelope, the way in which insulation is located in that envelope, and the waterproofing, how to keep it up, how to keep it warm, how to keep it dry. We encourage you to look at these detailed sections, and sometimes the plan and the smaller sections too, and work out for yourself how the structure works, where the insulation goes, and where the waterproofing, where the separation between the external weather and the interior environment, where that actually takes place. And in this case, you can see that the structure is the steel frame, which is supporting a timber box, which is sitting inside the existing building. There's very little insulation because it's relying on a box within a box, and so the glazing, which I've shown in a yellow line here, is the only proposal to isolate the inner environment of that box, the inner box, from the environment which is contained within the solid stone walls of the original old building. So there's a sort of zone, a buffer zone between the environment of the box on the interior and the interior of the original stone building. But nevertheless, the old stone building provides all the weather protection, and there you can see with the pink line the line of the surface of the stone on the outside of the building and the line of the windows in those openings. So the pink line represents where the weather stops and the interior environment begins. Another example, slightly simpler example in many respects, a typical project that you might be attracted to in a magazine. You might think, well, that's rather interesting. It's a little pavilion. It's some sort of visitor pavilion sitting in a lovely garden. It's got a simple enclosure. We can see in the detail on the right, there's a steel frame, quite a big steel frame in some situations. We can see that to the right top of the detailed drawing, where there's an enormous I-beam. And there are smaller I-beams to the right and little steel channels which are connected to those small I-beams to frame what looks to me like a roof light next to the gutter in the roof. And that all sits floating above the ground, as we can see in the photograph. And the section, the slab of the floor is suspended above the ground, and there's a little flight of steps going up onto that. And that sits on, again, a substructure of steelwork. So it's a very straightforward steel framed box. And you can see in the photograph and in the section, the external walls are relatively simple glazed walls, and the roof, which is quite thick, because it's got very few internal columns. The structure is spanning from side to side, has a long span, so the beams are big, and the roof is thick. So in the section, the small section that you can see in the middle of the left-hand page, you can see the relative thickness of the structure, the roof, and the external glazed walls. And on the right, you can see, and by reading carefully the list of the construction items, you can work out where the structure is, what's structural, what isn't structural, where the insulation is, and so on and so forth. And so the diagram that appears logically from the analysis of that detail section is that the main primary structural frame is horizontal beams in the roof and in the floor, columns which hold those in position, which are spanning from a beam resting near the ground at the bottom, and then supporting a column, which then supports a beam directly above that in the roof. You can see I've shown a blue dotted line where that column passes through the floor construction. And at the top, you can see two solid blue lines going up to meet the bottom web of the structural steel I-beam, which supports in turn a timber roof, which is on a slight pitch, because generally flat roofs are not flat, they are pitching. And you can see that the amount of insulation is relatively small in comparison to these great thicknesses. There's a little bit going around the roof light and under the gutter and across the roof at the top, and there's a slab of insulation in the floor slab on the ground floor construction at the bottom of the section on the right. Clearly, the external surface of the roof and the perimeter glazing of the glass box, that forms the weather protection to the building and carries on, in fact, underneath the ground floor slab, because the ground floor slab is sitting above the land on which the building is built, and therefore the pink line, which represents the separation between the outside weather and the inside environment, that is shown going all the way down underneath the ground floor slab in the gap between the ground floor slab and the ground below. A more traditional, perhaps, this more sort of refurbishment, a timber building. It's interesting to compare the thicknesses of the construction in this timber building. Looks like it's some sort of old house which has been converted into some sort of museum space or education space. The thickness of that external wall, which is shown in the detail in section, with a strange sort of detail at the head of each window, a sort of the timber cladding, I expect, although there's no photograph to tell us exactly what's happening, but we can see from the key that it might be timber cladding, boarding, is sort of canted out. It's sort of swung out a little bit at the top of each window, and there's a sort of lovely code section above each window, like a sort of eyebrow, which might be expressive on the outside of the building, and one would see the windows with this little eyebrow above each one, articulated on the facade. And above the section on the right-hand side, we've got the plan view of an external wall, very, very simple external wall where it's a timber frame, it's got boarding on the inside, it's got boarding on the outside. The timber windows are very delicate, they're very thin, they sit in that external zone aligned with the external boarding. It's a very simple, straightforward construction, and generally the insulation is contained within those structural timbers and forms a sort of blanket between those timbers. The timber, of course, in a traditional building like this being quite a good insulator. And there you can see that the structure of the building is, of course, the walls and the floors. They act as a sort of box-type structure. It's a very simple diagram, therefore, of the floors and the external wall being the structure. There's an indication, I think, on this detail that some of the internal walls, especially the one running down the middle of the plan, either side of the staircase, they are also structural, because the rooms will span from the external, the floors and the ceilings will span from the external wall to those central walls in a very simple way with sets of joists. Very simple construction. Here we've got a more complicated project. It's an old, I think it's a brewery. It's been converted into some sort of museum or gallery type space. And you can see how big it is from the section on the left-hand side of the double page spread at the top. You can see how big it is because those floors are probably, well, looking at the photograph on the right-hand side top, those floors are probably 3 or 4 meters high. So quite a large scale building, some sort of industrial type building. And you can see it's very, very, very long. So those in that section, we can see floors at maybe 3 meters separations. So the building itself could be almost 100 meters long. We see below that a photograph of that central section. We can see the profile in the upper long section. We can see the profile of the, what could we call that, a sort of Dutch gable end to that middle section. And we also see there's a new hole being carved in the face of the building, and some archways being created, probably indicating where the main entrance is. So the architects have decided to frame a new large opening which cuts through various floors and the external wall. And we can see also that the external envelope of the building is probably brick. And we see along the top edge of the roof in the photograph a modern addition, a roof extension. And we guess it's some sort of cladding, and we're not quite sure. But if we look at the detail section on the right-hand side, we can see that there seems to be a window in front of a wall, and in front of the window on the outside there seems to be a series of rectangular blocks which are spanning along the length of the facade, and we can see that some of those blocks have been rotated to open up little gaps so that we can see through, and we get the sense either side of that gable in the photograph that there are sort of louver type elements there which allow us a view out to the exterior from the interior. We can also see, and this is quite an important feature of these detail sections, and I'll cover it now, is that clearly that space between the wall and the glazing on the big section on the right-hand sheet looks very, very narrow and quite tall. But in fact, if you notice that there's a gap, a white line, a gap that appears to be running down between the internal wall and the external glazing, the editors of the magazine use these, they're called break lines, to be able to condense the information in a section to show internal and external wall construction all in the same detail. And they've also, you could see there are three horizontal break lines in the height of that section, which allow the vertical dimension of that section to also to be reduced to, again, condense the information. You don't have to draw everything out in proportion to tell you about the information of how the details, the connections between all the various elements, how they all work. And that's a very important feature, I think, of how one designs a building in detail, is that it's not so much the great long lengths of wall or glass or, in this case, some sort of louver that is of interest. It's where they join to other bits and pieces, and that's always the point at which you had to resolve how the glazing meets the ceiling, how the glazing meets the floor, and all of those sorts of criteria. And here we have a schematic where we show the blue structure. We show the pink line of the weathering. In this case, the louvers, of course, they're just louvers, probably stone, we think, in the key. They do not prevent the weather from blowing through those gaps, and so the waterproofing between inside and outside is dealt with by the inner wall and the glazing itself. So the glazing becomes the weathering surface. Sometimes it's also the insulation surface, and here again in this section we can see a great big thick slab of tapering, sloping roof insulation which sits behind a parapet and above the double glazing that is waterproofing the interior from the exterior. The building is slightly complicated too, because it has this double frame sitting inside the old brick walls, which have been reinforced. You can see in the right-hand section on the left-hand page that there's a double construction there of a brick and stone, perhaps, which are working together to form the external envelope of the building. And a bit like the house that we looked at right at the very beginning, there's a sort of inner structure, in this case steel, with a steel staircase, and the photograph on the left-hand side of the left-hand page, which we now pick up in the tiny section above, and in the photograph below it, we can see that that section shows the staircase, which is going up the inside of the external wall, past the windows, so you get a partial view out of the building as you walk past each window on the staircase, up to a floor level above. And the section, of course, is taken, in this case, halfway up the staircase, so the bottom half of the staircase is not there. It's the section is, as it were, cut through that staircase halfway up, and you did that little drawing of your staircase last week. You could maybe imagine having to cut a transverse section through your staircase in your studies, and show how that staircase is supported by the stringers, the side pieces that are going up from floor to floor, and how the handrail is supported by those stringers in turn, and that's clearly shown on this section. The right-hand page shows a photograph of some sort of service block, perhaps contains lifts or other rooms, which are specialist rooms, which have been attached via a sort of link to the main building behind. And here you can see in the photograph that it seems to be clad in a sort of panel which looks as if it might be weathering panel, but it's difficult to know. So what I've done in this sketch is I've shown the weathering panel as a solid pink line, but I've also shown an inner dotted pink line, which is in line with the external face of the walling behind and the glazing in the openings in that walling, as a secondary weather defence. So that external face of the building that you see in the photograph there is what we term a rain screen cladding. It will keep most of the rain out, but it won't keep all of it out. So there's a sort of inner layer to protect the building from the weather. And those two layers terminate at the top in a coping, and that coping runs down the back of the parapet and forms a waterproof layer on the roof. And on top of the concrete slab, which is shown in blue, there's a layer of yellow insulation on that. In some magazines, the point of the article might not be so much about the architecture, but might be about some sort of systems that the building is using. So in this particular case, we've got a multi-storey building with solar panels on the roof. We've got some sort of prefabricated modules on the interior. We've got a repetitive facade. We can see on the section on the left-hand page that there's an elevation on each floor, 1, 2, 3, 4, 5 floors, which is just repeated. Every floor is the same. There's an interesting basement with all sorts of different machinery and various pipes and ducts and fans and so on and so forth. So there's obviously some sort of plant going on there which is servicing these modules, and we can see a hatched connection between the basement and these modules, and various pipes and ducts passing backwards and forwards between the two. We get some sense on the right-hand page of the complication of the facade, and we're shown 2 floors here. We're shown maybe the 2 top floors because we can see the roof at the top of the section with very, very, very thick insulation and maybe a solar panel sitting on top of that. We're then shown 2 almost identical floors, the glazing right at the very perimeter of the building on the right-hand side of the detail, inner walls or inner glazing shown on the separate floors where there are, again, very thick insulation blankets thrown in there to obviously keep the thermal performance of this building at a very, very high standard. And we can see in the 3 photographs shown on the right-hand side the repetitive nature of that facade and various details of how the services and the building are integrated together. So there's an emphasis in this article about integrating the look of the building with its services. They are quite important. And again, we show structure in blue, insulation in yellow, a lot of it in this case, and the weather protection in pink. It runs underneath the solar panels, it runs around these projecting balconies, it runs back to the glazing and the inner wall on that upper floor. It's a very convoluted weathering system. The balconies are there to shade and to protect that inner line of glazing, balustrades, some sort of louver system maybe, sliding backwards and forwards. We are I think a little bit over halfway through, and we're coming to a series of, I think, quite interesting buildings. This top left-hand photograph shows a marvellous internal view, and I'd like you to consider in the section which is next to it, where you might be standing in that section to get the view that you can see in that photograph. I think that's a useful exercise for you to work out for yourself. Maybe you could print out that section and do a little markup where you're standing and what the angle of that view of that photograph is. And if you can imagine placing yourself in that section to get that view on the left, that's quite a good test of how good you are at reading plans and sections and elevations, etc. It's quite an interesting spread, this, because the detail on the right is, of course, of that ceiling and wall and the interior that we can see in the photograph. There's a rather nice relationship between that section with its little roof light of glazed bricks, which you can see in the photograph, centrally placed there in a sort of roof terrace, and that probably tells you, in terms of that smaller section on the left-hand page, where that detail is taken. And one of the other tricks, therefore, is to take the larger scale detail and work out where it is in terms of the smaller scale drawing. So transfer the right-hand page of information, as it were, at a different scale and overlay it at a different scale on the left-hand page. So hopefully you can see that that right-hand large-scale section is in that middle section to the centre of the upper section shown on the left-hand page. And I again show a simple diagram of the structure. Here they are horizontal slabs, which are, as you can see in the plans, supported by lateral spine walls, covered in insulation, the facade's covered in insulation and some sort of skin, probably a brick skin, which is both obviously weather protection and physical protection to the insulation, which we show behind in yellow. An interesting small house extension now, so we can see the form of the original house in the top left-hand section. We can transfer that because magazine editors are very good at arranging the drawings on the page. It's a good lesson for you. So if you're drawing that section at the top there, to draw the plan directly underneath, both the first floor plan and the ground floor plan, tremendously useful, because therefore you can read, as it were, the section and the plans together. They form a coherent set of drawings. The elevations are the three elevations of the new part of the building. They've not really focused very much on the older house. They've focused on the new extension, and they've shown part of that new extension in a photograph top right of the left-hand page. And then what's very nice is they've taken a little detail of the new extension, and they have made a strip photograph, a vertical framed photograph on the right-hand page, and drawn a section which I hope you can see and work out that directly follows the layout of that photograph. So the section on the right-hand side of the right page is a section, as it were, vertically down through those louvers, through the panel above the door, through the recessed door, through the front door step. And again, that's very simply followed up with a section which shows the waterproofing in pink, the recessed door at the bottom, the insulation, which is also contained, interestingly, here in the door, the floor, the wall construction and the roof, again with its tapering insulation on the roof to provide a slope for the roof to drain. Again, coming back to timber construction, we've got an interesting three-storey with basement house construction, very simple terraces of individual houses. We can see that the photograph shows us the assembly of all of these houses, whereas the plans above are of an individual house. So what this layout tells us is that the terrace of houses below in the photograph is comprised of a series of individual houses shown above with a basement. So there are three upper floors which are above ground and one basement floor. And if we move to the right-hand page, top left, we can see a section where we see how the basement sits underneath those three floors and what is happening on that top floor, which is cut back and is stepped. And so we then understand that top left plan is that plan of that top floor where the roof, the lower roof is set down and the external wall of the top floor is set back up that slope. And again, it's very typical of timber frame construction. The wall construction is relatively thin. There's a lot of insulation in the roof. The cladding, timber cladding in this case, and the windows and balustrades, etc., are very tight and taut in that facade. So everything's very delicate, very thin, very condensed and compressed. And there's a little porch element or shaded external element with a little polycarbonate roof externally. So that's shown as a separate little steel structure there on the detail section, and the floors, which are, in fact, I think the concrete floors for the bottom three levels and timber construction on the roof. I've drawn a little rectangle on that section around the part of the top left-hand section which is shown in the detail. So I've drawn a freehand dark box around that. This is quite a complicated house. It's a very very discreet, very underplayed facade. It's completely blank. It's got some sort of internal courtyard. We can see from the two sections, bottom left on the left-hand page, that it's perhaps an original house with a new extension running in parallel, and that the new extension has quite a large courtyard built behind a wall for some reason. Maybe it was a client who was very worried about their privacy. You have to read the rest of the article to find out why one might build, a wall 30 metres long with 4 little tiny windows in a beautiful orchard. It would be quite an interesting story, I'm sure, to work out why that was the final design they decided on. Again, blue, pink, yellow divisions into structure, insulation, waterproofing. Finally, I think this is the last one, a very unique stone museum in Japan. Of course, the Japanese, try to subvert everything they can, very successfully, I believe. On most occasions, the stone is not used, as you might expect, to hold up the building. Although it's a stone museum, the building structure is actually made of steel. And the stone, as you can see in that on the right-hand page bottom photograph, the stone is used merely as a sort of gigantic louver on the outside, and the upper right-hand photograph on the second page shows an oblique view of that. So it's a sort of cladding system which allows to show the use of the stone, maybe in an interesting way, which is sort of an untypical way, and so therefore exploring the potential of stone, but also in showing its tactile qualities, its colour, its texture, etc., etc. And here you can see they are stacked vertically, one above the other, and somehow connected back, as you can see in the bottom left-hand photograph on the second page, to some sort of steel structure behind. And there's the steel structure. I've shown it in blue. There's obviously some bracketry needed to support all those bits of stone, little shelving angles or something. The waterproofing is the internal glazing, which is set back from the stone inside, and the structure runs down behind the stone. The insulation very, very minimal at the underside of the roof membrane. And finally, an example of how you might explore an article in a magazine. I came across this strange Louis Vuitton flagship store, it said, in Guam. And for those of you who don't know, Guam is this tiny, tiny Pacific island in the middle of the Pacific Ocean, thousands and thousands of miles from anywhere. And one wonders, why Louis Vuitton would want a flagship store on such a tiny island. But of course, the reason they do is that it's one of the major Pacific bases for the American fleet. And there's lots of wealthy Americans, I imagine, walking around wanting to buy expensive French products. And I was intrigued by the photograph, the Louis Vuitton photograph. Quite complicated elevation. It's got some shop windows at the bottom, which I sort of could work out, but I could not work out what these yellow sort of rectangles were and what the pattern of the yellow rectangles meant. So I had to look at the plans, and I could see that the photograph is of that elevation, and I've drawn a line around the elevational parts of the section and plan on the left-hand side of the right-hand page. And then I've got a better idea from the photographs, which are shown on the right-hand corner of the second page, and I can start to see that it's some sort of clever louvered cladding system which is shading the interior of the shop from the external climate. And because Guam is this little tiny island in the middle of the Pacific, I've got a sense that it might be getting quite hot there in the summer, that a shading is needed. And, surely enough, by looking at the plan, I can see that quite a lot of the floor plan of the basement is full of mechanical equipment, air conditioning, and so on and so forth. So I'm thinking, yes, that's how this building is going to work. It's going to work because it's air conditioned. Although, strangely, this sort of perforated covering is trying to indicate that it's not air conditioned, but I don't think that's conveyed by the way the plans are labelled and the amount of floor space given over to air conditioning equipment. And then on the next page you can see what it's like, and it's a very, very interesting effect, very lovely interior light effect. And we can see how the perforated facade still allows the weather to get through. I've drawn some little lines in here with some arrows showing, a tropical storm blowing in, and the rainwater from that tropical storm being gathered by this enormous duct, which is running underneath, or gutter. And I've drawn in a rain pipe because they didn't seem to have a rain pipe in there. So I'm pretty sure there's a rain pipe in there, which will take all that water away. More to look at, more to think about. I hope you enjoyed the talk. Thank you.